where we will walk through Leetcode problems the easy way. Today, we're tackling Leetcode 35, search, insert, position. It's a classic binary search problem, and once you understand it, you see how elegant and efficient it really is. The task is simple. Given a sorted array of distinct integer and a target value, return the index of the target if it's in the list. If it is not in the list, return the index where it would be if inserted in order. Let's use binary search because it's perfect for already sorted lists. Start with the left pointer at index 0 and the right pointer at the very last index. Now we enter a while loop that keeps going as long as left smaller or equal to right. Inside the loop, find the middle index, and if the middle element equals the target, great, we just find the target. Return the middle index immediately. If the target is smaller than the middle element, move the right pointer to the left of the middle because we need to search the left side of the middle. And if the target is larger than the middle element, move the left pointer to the right because we need to search the right side of the middle. If the target is not in the list, the while loop will finally come to an end. The left pointer now will be the position where the target would be if inserted. Now we step through this algorithm using the below example. Watch carefully. This is where the logic becomes crystal clear. Define the left pointer, point to the very first element, and the right pointer, point to the last element of the list. As long as the left is not greater than right, then we do the following. Calculate the middle index, which is right here, and compare it with the target. 5 is greater than 3, then we need to move the left pointer to the right side of the middle pointer. Left is still smaller or equal to right, then we need to recalculate the middle pointer. At this time, it will point to 5. And now we're going to compare 5 with the target 5. We found it, then we return the index of 5 within the middle. So we return the index of 5, 0, 1, 2. We return 2. Moving on to the next example, we need to find 2 inside the array. First, we set up the left and right pointer, which point to the very first and very last elements in the array. Now we enter a loop as long as left is smaller than or equal to right. Then we calculate the middle. We find the middle element, which is here, and we compare 3 with the target 2. So 2 is smaller than 3, then we need to move the right pointer to the left of the middle because we need to search the left side. Left is still have not greater than right, then we still continue the loop. Recalculate the midpoint, point to 1, and compare middle element 1 with target 2. So 2 is on the right side of 1, so then we need to move left pointer to the right side of the middle, which is 3 right here. At this time, left pointer is greater than the right pointer, then the loop terminated. The position of the target 2, if it would be inserted into the array, is at the left index 0, 1. So this position is 1, and we return 1, where is number 2 would be inserted in order. Let's move on example 3. We need to find target 7 inside the array, or if not there, then find the position where it should be. First thing first, we set up the left pointer and the right pointer, which point to the first and the last elements of the array. As long as left has not surpassed right, find the middle pointer, which is right here, and compare 7 with 3, the middle element. So 7 is on the right of 3. Move the left pointer to the right of 3. The left is still not surpassed the right pointer. Then we need to find the middle element between left and right and compare 7 with the middle element 5. 7 is on the right of 5. Then we need to advance the left pointer to the right of the middle element. Since left still have not surpassed the right pointer, the operations continue. We need to find the middle pointer between left and right. So the middle pointer also point to 6. Then we compare 7 with 6. 7 on the right of 6. We move the left pointer to the right of 6, which will point to here. Now, at this time, the left pointer surpassed the right pointer. The while loop terminates, and we return the left pointer at position 4. Position 0, 1, 2, 3. So position 4 is the index or the position where target 7 would be if inserted in the array in order. Alright, now let's translate this logic into Python code. First of all, we set the left and the right pointer point to the first and the last elements. So now we enter the while loop. As long as the left index has not surpassed the right index, we do the following. First, we find the middle position. We integer divide. So in Python, integer division means we divide and we float it down to the nearest integer. For example, 5 integer divide 2 is 2. Instead of regular division, 5 divide 2 is 2.5. 7 integer divide 2 is 3, not 3.5, not a regular division. Alright, keep moving. So we got the middle position. We compare if target is the same as the middle elements. Then we found the target inside the array. Then we just return its position. Else, if the target is smaller than the middle elements, we move the right pointer leftward to the left of the middle pointer. Middle minus 1. Put 1 position. Else, the last case, we do the opposite. We move the left to the right of the middle element. If the target is not in the array, the while loop at some point will terminate. Left will be the position where the target would be if inserted. So we return left index or left pointer. Alright, and we're done. That was clean, fast, and to the point. A textbook binary search. Let's hit that submit button. Boom. One shot. Accepted. If that helped you cross this problem, drop a like and subscribe for more walkthroughs like this. Catch you in the next one. Thanks for watching.